All right, go and take your textbooks out. Turn to page 425 and ask you to do numbers 1, 2, and 5 on page 425. Also asked you to do numbers 1 through 3 on page 440 to 441. You want to have your homework out and your books open to those pages. There's 1, 2, 5. There's your, I missed the 1, 5. There we go. 1, 2, and 3. Excellent. And 1, 2, and 5. And 1, 2, and 3. Excellent. So practicing. The entire homework assignment was just reading 6 graphs. Number 1. On page 425, a gas station relocated its water bottles and candy bars to the front counter. The graph on the right compares their sales in each location. Were there more sales with the items in the original or new location? Joshua?
New.
Definitely with the new location there at the front. Number 5, or letter B. How many more water bottles were sold in the new location than the old? So first you had to figure out how many water bottles in the new location, how many in the old. Well, the old is easy, Lana. How many water bottles in the old location?
It was 90.
90. And in the new location, the whole bar goes up to 230. So if 90 were the original, then in the new location, that would be how many?
Keep looking at 140.
Okay, so 140 new, 90 old, that would be a difference of 50 water bottles. Letter C. Approximately how many candy bars were sold in the new location than in the old? You do the exact same process. And Joshua, what'd you get for letter C?
91.
Ooh. Let's see, I've got 60 in the old location, right? And I've got, that total bar goes up to 155, it looks like. So if 60 were old, and the whole bar only goes up to 155, you have to subtract to get 95 in the new location, right?
Oh, yeah.
60, 95 minus the 60, or the 155 minus the 60 is 95. So 95 new, 60 old, how many more? 35 more candy bars. Good. Does it make sense there?
Well, I had the answer,
But you changed it?
see, I have 35 written out to the side, and then I circled the wrong answer.
Ah.
Like,
All right. Questions on that stacked bar graph? Let's take a look at number 2. Grand opening feedback. 110 survey customers gave a poor rating. How many people must have been surveyed if 110 customers gave a poor rating? Joshua?
11.
Well, 11% of all the customers said poor, right? But that 110 is the 11%, right?
Oh, wait.
Right, the 11% is the 110, so 11% of what? In other words, we could say that 110 is 11% of the total people surveyed, correct?
Yeah.
So what would I do to solve here?
You, 110 times 0.11.
110
Divided by
110 is 11% of the total people, right? Because 11% of the total is how many said poor, and that's 110. 110 is 11% of the total. So if you can write this as a percent statement, it'll tell you what to do. We should have gotten anyone?
1,000.
1,000 customers. Then, using this answer, if there were 1,000 customers, and so Joshua, this would be incorrect on your end then, if there were 1,000 customers total, Lana will go to you, how many people gave an excellent rating?
570.
570. Since 57% said excellent, if that's 57% of 1,000, that would be 570. And how many did not give a poor rating? What percent did not give a poor rating, Joshua?
89.
89%. Questions on A and B. Questions on A and B. All right, let's take a look at number 5. We have some running times for a 5K. And their times are getting better and better and better as they run longer and longer.
Would you say for A on the...
There were 1,000 customers.
Yeah. Oh.
You got it now, or?
I think so.
Okay. So going on to the line graph, the goal was to drop times by at least 4 minutes. Which of the two guys actually dropped their time by 4 minutes? Joshua? Well, look at Jeremiah. He started at 27, and he dropped to 22 and a half minutes. So he actually dropped by 4.5 minutes, didn't he? Jeremiah met the goal. Now, Ryan, on the other hand, Ryan went from 26 to 23. He only dropped 3 minutes on his time. Does that make sense? All right. For which month did someone's time actually increase? What was the rough month for somebody? Class? May, right? So Ryan kind of leveled off there for a little bit, and a little bit of a not as good, and then he got better again. And then what was Jeremiah's time in March? Joshua?
25 minutes.
25 minutes. Questions on 1, 2, and 5.
On number 2, letter A, how many people were studying?
1,000.
Yeah. And then for B, I put 1,000.
Okay. So Joshua, 11% of the entire graph said this is bad. This is real bad, right? 11% of all the people. And they're telling us that this right here, this 11% is actually 110 people are included in that 11%. The question is, what's the whole number? The 110 is 11% of all the people. So we translate that into algebra and say 110 equals 0.11 times x, because we don't know the total. Divide away the 0.11, move the decimal twice in each case, and obviously 11 being divided into 11,000 is going to give us 1,000. Once you know there's 1,000 people, if 57% said, hey, this is excellent, well, there's 1,000 people total. We now know that, so 57% of 1,000 is 570. Does that make sense? So basically, whenever you work with a circle graph, you're dealing with percents, which means percent statements need to be written. And do you remember a couple lessons ago, I think it was homework, we did nothing but percent statements in the homework one night? It was because we were coming up to this and working with percents and the frequency tables, right? The relative frequency tables also dealt with percents. But that was part of the reason there. All right, let's turn over to page 440. Page 440. And let's take a look at the homework there. Numbers 1, 2, and 3 this time.